Now in this example 2, I shall illustrate how to solve definite integration problems, definite integrals, when the integration problem involves a substitution. Alright, so this is slightly different from example 1 that you have seen, because this problem here involves a substitution. Now before we do the substitution, or before I illustrate the method, we have to understand certain ideas first. Now this definite integral over here is saying that we need to integrate this expression x square root x plus 2 with respect to x, and it's a definite integral where the lower limit is -1 and upper limit is 1. Now we have to understand the upper limit and the lower limit, -1 and 1, they actually refers to x values. So in other words, this 1 actually refers to x equals to 1, and this -1 here actually refers to also x value. It's called x equals to -1. It makes sense because we are integrating with respect to the variable x, so that is why whatever values I give here should be x values. So say again, the values here should correspond to the variable that you are integrating with respect to. Now since this example involves a substitution, which means later on you're supposed to replace all the variable x to a new variable called t, because t is the variable here, which also involves subsequently, if you do the substitution, subsequently your dx here will eventually become dt, because it's a substitution problem. As such, whatever values here shouldn't remain as -1 and 1 anymore, because now you have reduced it to an integration problem with respect to t. Therefore this should be a t value, and likewise this should be a t value. Alright, so let me illustrate what is this point talking about. So first thing first, this is a substitution. Now later on in doing the substitution, you will need to change the limits from x values to become t values. How to do that? Well, you're given a substitution, and we know that this is x equals to -1. So when x is -1, you work out what is the t value by using the substitution. How to do? Here. So 1 here refers to the upper limit. Alright, when x equals to 1, which is the upper limit, you substitute x equals to 1 into the substitution, you get t equals to square root 3. So later on, this square root 3 will be the new upper limit. Likewise, you will need to find the new lower limit later. How? You know that the lower limit currently is x equals to -1. So when you sub x equals to -1 inside the substitution, you get t equals to 1. So this t equals to 1 is the new lower limit. Okay, now we are ready. We can do our integration as per normal. To do a substitution integration problem, as what you have done in the previous chapter, step 1, you will differentiate the substitution. Now differentiating the substitution gives me this thing, dt equals to this expression dx. So you make dx the subject, you get this expression. Alright, so now I am ready to do the substitution, really similar to what you've done in the previous chapter. Now let us ignore the limits first. Do the substitution. We don't know what is x in this case, but we know that the substitution is t equals to square root x plus 2. If you square both sides, you're going to get t squared equals to x plus 2, which means x is actually t squared minus 2. Make sense? So this variable x will be replaced to become t squared minus 2. Next, square root x plus 2 is just t, replace it by t. And last but not least, dx. dx is given by this expression, and we know that square root x plus 2 is in fact just t. So dx is equals to 2t dt. So dx, we can replace it by 2t dt. Well, isn't this the usual things that you would do for a substitution problem? Now you will realize that we have reduced an integration problem which involves variable x to an integration problem which involves variable t. Now, because the new variable to integrate with respect to is t, that is why I need to change my limits to t values. When x was -1, we get the new limit to be 1. Now, this is a t value now. When x was 1, the upper limit, the new upper limit now, which is a t value, is square root 3. Alright, so when you do an definite integration problem that involves substitution, you must change the upper and lower limits accordingly. So what follows is very easy. You simplify the expression a little bit, you're going to get this. 2 t square bracket t square minus 2 dt. Alright, then now it's just a normal integration problem with definite integrals. So how do you do? First, you integrate the expression. To integrate this expression, of course, we take out the constant 2 and we expand out, which we get t power 4 minus 2t square. Lower limit 1, upper limit square root 3. So what do? We integrate as per normal. You get this? Not forgetting the way to present when it involves limits. You write a square bracket with the limits at the right hand side of the bracket. Lower limit, upper limit, still in t values. And after which, all you need to do, substitute the top limit into the variable t, which you get this. Substitute the lower limit into the t, which you get this. Right? So this is how you deal with limits. Now take note that limits, to compute limits, this sign is always minus. You always substitute the top limit minus you substitute into the bottom limit. Okay? What follows is just some simple arithmetic, which you will be able to get this. Okay? So this is how you solve a definite integration problems involving substitution. One key point to take note is that you need to change the limits. Okay? So let me illustrate one more example. Example 2b. This is a question that involves trigo now. Okay? So, same thing. We're given a substitution, x equals to sine square theta. We're supposed to find the exact value of this definite integral. Take note, exact value. Now, this is the lower limit, 0. This is x equals to 0. And the upper limit is 1, which means x equals to 1. Why x? Because the variable that this problem is integrating with respect to is x. Okay? So what do we do? Later on, you're going to change the variable x to become theta, the new variable, which is why we need to find the new limits. So, same manner, when x equals to 0, the lower limit, when x equals to 0, you plug in 0 into x in the substitution, you solve for theta. So now you obtain theta equals to 0. So theta equals to 0 refers to the new lower limit. Likewise, when x equals to 1, which is the upper limit, you substitute x equals to 1 into the substitution, you get sine square theta equals to 1, which reduces to sine theta equals to 1. Alright, then all you need to do, solve for theta, you get theta equals to pi over 2. Now, theta equals to pi over 2, this is called the new upper limit. Clear? Alright. What follows? You follow the exact same steps as we have done for integration problems involving substitution, where step 1 involves differentiating your substitution. So dx will be equals to 2 sine theta cosine theta d theta. Alright? Step 2, you will put in all the variables. You replace all the variables in x to become the new variables theta. So integrate square root 1 minus sine square theta divided by sine square theta. Okay? Dx become 2 sine theta cos theta d theta. Now, because the new variable that you're integrating in respect to has been changed to theta, that is why the lower limit and the upper limit have to be theta values. So, when x was 0, theta will become 0 as well. When x is 1, theta is pi over 2. Alright, so let me remind you one more time. We need to change the upper limit and the lower limit accordingly. Okay? So let me carry on. What follows is just a normal integration problem. Integrating from 0 to pi over 2. Square root using trigo identity. 1 minus sine square will give me cosine square theta over sine square theta. D theta. Because we are only concerned about the principal values, so that is why we square root the cosine square and the sine square, we don't get modulus. So we're gonna get cosine theta over sine theta times 2 sine theta cos theta d theta. With that, we can easily see that sine theta can be cancelled off, and we are left with integrating from 0 to pi over 2 to cosine square theta d theta. Now you realize that even in definite integral problems, you also need to be very good in the normal integration techniques. So how do we integrate cosine square? If you recall, integrating cosine square requires us to use the double angle formula. So making cosine square theta the subject, you get this. So we're gonna get integrating from 0 to pi over 2 cosine 2 theta plus 1 d theta using double angle formula. Continuing, now we integrate as per normal. Integrate cosine 2 theta is very easy. You get half sine 2 theta. Integrating 1, you get theta. And because there are limits, we put a square bracket with the limits at the side. Okay, what do we do with the limits? You simply just plug it in. Top limit first. Pi over 2, substitute into here, you get sine pi plus pi over 2, substitute the top limit. This is the value you obtain by substituting the top limit into the variable theta. Now you need to minus, put a big bracket, minus 2. Now you substitute the lower limit, which is 0, into theta. So you get half sine 0 plus 0. Alright, so the answer is very nice. Sine pi is 0, pi over 2 you're left with here. Sine 0 is 0, 0 plus 0 is 0. So the final answer, pi over 2. And of course, you don't evaluate using your calculator because the question requires you to leave your answer in exact form. So I hope via this example, you have illustrated how we can solve definite integration problems involving a substitution.